Welcome, ladies and gentlemen. Today we are going to be discussing areas of trapezoids, rhombuses, and kites. So you will need your notes, a calculator, and a pen and/or pencil, and we will begin. This first one here, ladies and gentlemen, needs to go on to your formula sheet. Okay, so we're going to talk about trapezoids. Now, the height of a trapezoid, once again, is the perpendicular height. That's very, very important. Our height has to make a right angle. Okay, so then once we know that, we can do the area of a trapezoid. Area of a trapezoid is 1/2 the height times base 1 plus base 2. So our B's right here stand for our base. Okay, I highly recommend that you write this down and that you draw the picture in your table so you have something to reference. Okay, so area of a trapezoid, 1/2 height times the quantity base 1 plus base 2. All right, here we go. We're going to do a little example, so this one can go into your notes. Don't worry about making the picture exactly like this. You can just draw a trapezoid. You don't have to actually draw the chest of drawers. So the front of this chest of drawers is a trapezoid. As shown, we need to find the area of the front. So if we use our formula for trapezoid, area equals 1/2 times the height times the quantity base 1 plus base 2. So area equals 1/2 our height, which is our vertical height right here, which they display over here for us, is 20. Times our base 1 plus base 2. So it doesn't matter which one you call 1 or 2. I always do the top one as my 1 and the bottom one as my 2. So I'm going to have 12 plus 18. Go ahead and simplify this. I get area equals, well, half of 20 is 10 times 12 plus 18 is 30. And 10 times 30 is 300. So the area of my chest of drawers is 300 inches squared. Now we're doing squared because we're talking about area. All right. That's all we have for that one. Make sure you have this in your notes. This next slide here, we're going to talk about more formulas, so make sure this goes onto your formula sheet. We're going to talk about the area of a rhombus. The area of a rhombus is 1/2 D1 times D2. Now, make sure you guys get the picture of this one too. D in this case, ladies and gentlemen, D stands for diagonal. All right, we have two diagonals going on. Also that deals with diagonals, we're going to talk about kites. The area of a kite equals 1/2 the diagonal 1 times the diagonal 2. So we have the same formula to find area for trapezoids and kites. So I highly recommend making sure we have both these formulas written down and the pictures for these ones in case we need to go back and reference them. All right? Okay, we have a few examples and then we'll be done for the day. Here's our first example. We need to find the area of the rhombus and the kite. So we're going to start here with a kite. We know it's a kite because we know that two disjointed pairs of sides are congruent. Now to find area of a kite, we're just going to take 1/2 diagonal 1 times diagonal 2. So area equals 1/2. This is a diagonal right here, so I have 14 times diagonal 2. Now here's my other diagonal. It's very important that we remember our properties of kites and rhombuses because these two are congruent. So this is 4 and this is 4. So my second diagonal is 8. Now if I go through and I'm simplifying this, area equals 7 times 8. So my area is going to equal 56 units squared. All right. Now we're going to find the area of this rhombus. Now we know it's a rhombus because all of the sides are congruent. also important thing to know about rhombuses is that the diagonals bisect each other. So if this is 2.7, this side also has to be 2.7. And if this is 1.4, this side also has to be 1.4. Now we can plug it into our formula. So area equals 1/2 diagonal 1 times diagonal 2. So my area equals 1/2. If I take 2.7 plus 2.7, I'm going to get 5.4. Times my diagonal 2, 1.4 plus 1.4 is 2.8. Simplify this. Half of 5.4, I get area equals 2.7 times 2.8. So my area of this rhombus is 7.56 units squared. All right, moving on. So these are how you find a area of a rhombus and a kite. Make sure you're getting all these examples in your notes, all right, ladies and gentlemen? We have 3 more examples. These next 2 examples, I'm going to give you information. I need you to find x. So if we look at this first one, I tell you that the area of this, well, all the sides are equal, so this rhombus is 300 meters squared. And then I give you some information on the inside. So first thing, if I'm talking about a rhombus, I'm talking about the equation A equals 1/2 diagonal 1 times diagonal 2. So it's very important that I know at least one of my diagonals because I know my area is 300. So I have 300 equals 1/2. Now if I look at my diagonals up here, this portion right here is x. Now we know the diagonals bisect each other, so this is also x. Do the same thing here. This right here is 15. This side over here is also 15. So my diagonal 1 is 30, and my diagonal 2 is 2x, because I have 2 of them. X plus x is 2x. Now I'm going to go ahead and simplify this. I'm going to get 300 equals 15 times 2x. Now I can combine my 15 times 2x, so I get 300 equals 30x. Divide both sides by 30, and x equals 10 meters. All right. Moving on. Now we need to find x in this. Now this one here is a trapezoid. Now to find the area of a trapezoid, I get 1/2 the height times base 1 plus base 2. So I'm going to go ahead and plug in everything I know. I know my area is 39, so 39 equals 1/2. My height here, because I have my perpendicular, is 6. My base 1, I'm going to call right here, I have x. My base 2 is 9. So now I'm going to simplify and solve for x. So 39 equals, well, half of 6 is 3, x plus 9. Now I'm taking 3 times this quantity. So to get rid of it, I'm going to divide both sides by 3. So 39 divided by 3 is 13 equals x plus 9. So this, I'm going to subtract 9 from both sides. And I'm going to get 4 centimeters equals x. So there's my x. There's my other base value. All right, ladies and gentlemen, last one. We need to find the area of this shape. Now, this shape is 2 shapes put together. The one in the center right here is a rhombus. All sides are congruent. Now, the shape connected to this right here is a shape we have already learned. This is a parallelogram. So in order to solve this problem, I'm going to have to find the area of the rhombus and the area of the parallelogram. Excuse me. Before I go ahead and do that, I'm going to plug in everything that I know. So anything with 2 lines is going to be 5. Anything with 1 dashed line is going to be 4. So I'm going to go with this. All my side lengths are 5. Here I have 4 and 4. So if I set up my equations now, I have area of a rhombus equals 1/2 diagonal 1 times diagonal 2 plus the area of a parallelogram, which is base times height. Now, but while I'm plugging this in, I come across two problems. My first problem is my rhombus, I only know one diagonal. My second problem is my parallelogram, I don't know my height. Okay? In order for us to find that, we need to find this right here. This is my height and half of my diagonal. Now, since I have my right angle here, I can use the Pythagorean theorem. So I'm going to call this x. So I have x squared plus 4 squared equals 5 squared. So x squared plus 16 equals 25. Subtract 16 from both sides. X squared equals 9. Take the square root of both sides, and x is going to equal 3. Now this is going to help us a lot because it's my height and it's part of my diagonal. So if this is 3 and this is 3, I can now solve this problem. So I'm going to plug in everything I know for my rhombus. So area equals 1/2. Diagonal 1, I'm going to call this one right here. So 4 plus 4 is 8. Times diagonal 2, 3 plus 3 is 6. Go ahead and simplify this one. I get area equals 4 times 6. So my area equals 24. So there's my area of my rhombus. Now I need to find the area of my parallelogram. Now it's very important to remember area equals my base. Here's my base right here, my 4. And my height has to be my perpendicular height. That's why I needed to find that 3. So the area of the parallelogram is just 12. Now my total area, to find my total area, all I have to do is add those up. So I'm going to have 12 plus 24, which is going to give me 36 units squared. All right, ladies and gentlemen, that was our last example, so that's all I have for you today. Enjoy the rest of your day, and I will be seeing you later. Bye.